Up to this point, we've looked at a couple different ways to solve quadratic equations. So this is equations that have x squared in them. Now, we've looked at things like factoring and taking the square root. These are things that only work in very specific cases. So we have not yet looked at a way to solve any quadratic equation. That's what we're going to look at in 4.7. So this is a bit more involved because this is a bit more robust, because this is a way that you can solve any quadratic regardless of what it is. Anything you're given you can solve using this method. So it's a bit more involved, it's a bit more robust. Now there's a bit of setup that we need to do, so that's what this video is going to be about. This video is about kind of getting into the completing the square and the preliminary knowledge that you need for that. The next two videos then will be on actually doing the calculations involving completing the square. Okay, so let's start with something like this, x plus 5 squared. Let's multiply this out. So x plus 5 squared, that's x plus 5 multiplied by itself. Now I should point out that this is what I see a lot of students doing when they try to square something like this. They say that it's x squared plus 25. This is absolutely wrong. So when you multiply x plus 5 squared, that's going to be x plus 5 times itself. You need to FOIL in order to get this. So this is wrong, wrong, wrong. Don't do that. All right, so x times x is going to be equal to x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. Now we've got like terms in the middle, and we can combine those together. You'll notice that those like terms are the same. They're both 5x, and so when we combine them together, we get 10x. This is important. So we get the same thing in the middle, and that happens when we square something, when we multiply something by itself, a binomial by itself. This is going to happen every time, where we get the middle two terms here that we combine together. To get that new middle term, they are going to be the same when we're multiplying the same thing by itself. And so what we can see here is that when we multiply this out, then the middle number is just 2 times that number, because we've got 2 of them. And then the last number is that number squared. So if we have x plus 5 squared, the middle number is twice 5, and the last number is 5 squared. And so if we're going to start factoring these, we can use that fact. So if you look at x squared plus 8x plus 16, well, we could think about doing exactly what I was talking about here. Let's maybe do this in the way that you guys are more familiar with. So we're going to look at 16 and try to find factors of 16 that will add or subtract to be 8. And so we could do 1 times 16, 2 times 8, or 4 times 4. Well, 4 and 4, those are going to add together to be 8. And so what this would factor to is x plus 4 and x plus 4. And so you can see we've got the same binomial. So we could actually write this as x plus 4 squared. For the second one here, actually let's go back to this for 1 second. So 4 is half of 8, and it is the square root of 16. Or another way to say that is that 8 is 2 times 4, and 16 is 4 squared. So if we're looking at, say, this one, well, 18 cut in half, that's 9, although it's negative 18, so it should be negative 9. And then negative 9 squared is 81. And so this one will factor to x minus 9 times x minus 9, or you could think of that as x minus 9 squared. Now this one here, this one has some numbers in front and back, but what this one will factor to is 2x plus 3. So you can see 2x is the square root of 4x squared, 3 is the square root of 9, and if we were to multiply 2x times 3, we would get 6x, double that, and we get the middle term. All right, so we've got some rules here for, these are called perfect square trinomials because they are a perfect square. They're square of a binomial. So if you have a plus b squared, then this is what you're going to get. And here's an example of that. Or if you have a minus there, then you're just going to end up with a minus right here. And again, there's another example of that here. All right, let's look at some equations here that we could solve by using exactly what we just did. So you'll notice that x squared plus 6x plus 9, this is a perfect square trinomial. And we can tell because half of 6 is 3, and then 3 squared is 9. So this is a perfect square trinomial. We can factor it just like the other ones up here. So x squared plus 6x plus 9, that is the same thing as x plus 3 squared. Now if you don't believe me, you could check that, multiply it out, and you'll see that you will get x plus 3. Now if you're having a little bit of difficulty seeing the pattern here, just try factoring it like you would normally factor it. So think about two numbers that would multiply to be 9 and add to be 6. Those two numbers are going to be 3 and 3. Okay, so then we get x plus 3 is equal to 36. Well, now we can take the square root. So we take the square root of both sides, and squaring and square root cancel off. We're just left with x plus 3 over here. And then we get plus or minus the square root of 36. Well, the square root of 36 is 6. And so then what we can do is we can split this into two different equations. So one of these, this is really two equations packed into one here. So one of them says that x plus 3 is equal to 6, and the other one says that x plus 3 is equal to negative 6. Then to solve, we could subtract 3 from both sides. We get 3 here. And if we subtract 3 from both sides, here we get negative 9. So those are the two solutions to this equation. Let's do another one of these. All right, x squared minus 10x plus 25 equals 16. So let's factor this one. So again, we could follow these rules up here, or you could think about we need two numbers that are going to multiply to be 25 and add to be negative 10. Those two numbers they're both going to be negative 5. So this factors to x minus 5 squared. Now we can take the square root. Square root of anything squared is just that thing. And then on the right side, we get plus or minus the square root of 16. Square root of 16 is 4. So again, we end up with two equations. One of them is that x minus 5 is equal to 4, and the other is that x minus 5 is equal to negative 4. Now if we add 5 to both sides, we get x is equal to 9, and add 5 to both sides here, x is equal to 1. So these are the two solutions then to that equation. All right, let's do a little bit of filling in missing terms. So let's see what we would need to put in this middle spot in order to make this a perfect square trinomial. So again, what we'd be looking for is taking the square root of this last number and then doubling it, right? So if we take something like, where was it? Here. So 16 and 8, take the square root of 16, that's 4, double it, and we get the middle number here. We're going to do the same thing to fill this in. So the middle number here should be square root of 49 is 7. Multiply that by 2. We should get 14, and then the middle term should have an x on it. Since, when you think about multiplying this out, you would get x times 4 and then 4 times x. That's going to give you the x's in the middle term. All right, this one here, the middle term is negative 12. So we can think about, go back up to one of these, say negative 18, cut that in half is negative 9, square it is 81. And again, the reason why it's being cut in half or squared, if you think about multiplying this out, if we were to take, let's just take this for a moment, let's say that we were to take x minus 9 and multiply that out, x times x is x squared, that's negative 9x. This is another negative 9x, so we've got two negative 9's right here. 2 times negative 9 is negative 18, which is that middle number. And then for the last one, we do negative 9 times negative 9. That's negative 9 squared, which is positive 81. So see, we've got two negative 9's here, so the middle number is 2 times negative 9. And then the last number is the last squared, negative 9 times negative 9. So again, if we take this negative 12, cut it in half, that's negative 6, square it, and we get 36. For the middle number here, take 121, square root it, that's 11, double it, and we get 22. Last one here, x squared plus 16x. Well, cut that in half, we get 8, square that, and we get 64. If we wanted the factorizations of these, so this one would be x plus 7 squared. This one would be x minus 6 squared. This one would be x minus 11 squared. And this one would be x plus 8 squared.